Okay, this is part B for section 4.3 about logarithms. We got cut short unexpectedly. Had to rearrange some things. All right. Okay, here we are on number 2. So, okay, 1, 0, and then 3, negative 1. Okay. 1/3 and 1 is like around there. Okay. So because that base is a fraction, it's just kind of flipped upside down. But it still has a domain from 0 to infinity and range of all real numbers. All righty. Number 3. All right, log base 3 of x minus 2. So this is a horizontal shift. Okay, so we have to recall back to what we did in chapter 2. Okay, so that minus 2 is going to shift the function 2 units to the right. Okay, so remember that, okay, so because this minus 2 is in the parentheses with the x, then that means that it's something that applies to the x's, and everything that applies to the x's is like the opposite of what it says. So if it says minus 2, it really means we're going to add 2 to the x values. Okay, so let's think of log base 3 of x as the parent function. So the table for that then would be 1, 0, 3, 1, and 0 undefined. I'm not going to worry about the fraction. And then we're going to add 2 to the x's. Okay. So the y's will stay the same. 0, 1, undefined. And then take those x's and add 2. So that would be 3, 5, 2. Okay, so because of the fact that we have shifted the function 2 units to the right, our vertical asymptote has been shifted 2 units to the right, because wherever it says undefined, that's your asymptote. So that's our vertical asymptote. So the vertical asymptote is now at x equals 2. Okay. Okay. All right. So 3, 0, 5, 1. Okay, so it's just the same, but it shifted 2 units to the right. So when we look at this, now we can see that our domain is now from 2 to infinity with a range of all real numbers. All righty. Number 4, we have y equals 3 plus log base 2 of x. All right, so this is a 3 being added, but it's not in parentheses with the x. So that means it's something that's applying to the y's. So we would basically add 3 to the y's. And I think the reason why they would put that in the front like that is to make it a little bit more obvious that it's not attached to the x. So like, let's see, we could so we could write it like this: log base 2 of x plus 3. But again, we want to make sure we know that that plus 3 is not attached to the x. So you could also like emphasize that by writing it like that maybe. So that looks a little bit more like maybe what we're used to. All right, so our parent function would be log base 2 of x. So that would be 1, 0, 2, 1, 0, undefined. And then add 3 to the y's. So in this case, x's stay the same. And then with undefined, you can't really do anything to it, so that stays the same. And we're just going to add 3. So that would be 3, that would be 4. All right, so our vertical asymptote is still at 0. X equals 0. Okay, then we have 1, 3, and 2, 4. Okay, so just shift it up. So the domain in this case is still just from 0 to infinity. The range, all real numbers. Okay. Okie dokie. Number 5. So we have log base 1/2 of 3 minus x. Okay. All right, so for our parent function then, let's say it's log base 1/2 of x. So we still have the 1, 0. Then this would be 1/2, 1. And then it would be 2, -1. So the reciprocal with -1. And then 0, undefined. Okay. All right, let's see here. Let's rewrite this a bit. Okay, log base 1/2 of, so let's say that's negative x, so, or negative 1x plus 3, okay? Okay. So we have two different things that we have to do to the x's in this case, and the y's are going to stay the same. So the y's are going to stay the same. I'm going to skip the fraction-y one. I don't need that. So I'm just going to kind of skip this one because really, who likes fractions anyway? All right, so, okay, now with the x's, so remember everything that we do to the x's is like reversed from what it looks like. So what we're going to do with the x's is we're going to first subtract 3, then divide by -1. Okay. All right, so it's the opposite operation, and it's also like in reversed order of what you'd think it was. All right, so 1 minus 3 would be -2, divided by -1 would be +2. 2 minus 3 would be -1, divided by -1 would equal +1. 0 minus 3 is -3. divided by -1 would be +3. Okay. All right, let's see. So there's my vertical asymptote is now at 3. X equals 3. Okay. All right. And then, okay, 2, 0. 1, -1. All right, so it's flipped all kinds of ways. Okay, and there's our graph. So now by looking at the graph, we can see that the domain is actually -infinity until 3 parentheses. And then the range is still all real numbers. Okay. All right. All right. All right, so that's it for the graphing of logs. We'll move on to rules of logs. All right, so the rules of logs go along with the rules of exponents, which, like I said, we're hoping that you already are familiar with. And again, if you're not, you can go to my Math 0342 playlist and go to section 13.2/13.5, and that's all about exponent rules. Okay, some of them I've already mentioned in this video and others. So we have log base b of 1 is equal to 0 for any value of b. So any log of 1 is always equal to 0. And then we have what we call the common log right here. All right, so if the base is not shown, then it's understood to be a base of 10, okay? And then this is saying log base b of b to the n equals n. So it's basically telling you that log base b cancels out an exponential base b, okay? And that's just true because of the fact that logs and exponentials are inverses of each other, okay? All right, so simplify without using a calculator. So log base 3 of 9. So what we would do is we want to rewrite the 9 using the base of 3. So 9 is the same thing as 3 to what power? Well, we know that 9 is the same thing as 3 squared. So then these can cancel each other out, and the final answer is just equal to 2. Okay. And then number 7, log base 5 of 1. So like we said a second ago, like it says up here, any log of 1 is always equal to 0. And then number 8, log of 100. So it doesn't show any base. So we know that the base is understood to be 10. Okay, so then we want to try to replace the 100 with 10 to a power. So 100 is the same thing as 10 to what power? Well, we know that 100 is the same thing as 10 squared. And then we could cancel out log base 10 with 10, and the final answer is 2. Okay. Number 9, log base 2 of the square root of 2. So we want to try to replace the square root of 2 with 2 to a power. Okay, so that's log base 2 of, so the square root of 2 would be the same thing as 2 to the power of 1/2. Okay, so the square root is the same thing as a 1/2 power. Okay, so then we can cancel out log base 2 of 2, and your final answer is just equal to 1/2. All right, number 10, log base 1/3 equals 81. Okay, so we would be trying to replace 81 with 1/3 to a power. Okay, so let's see here. All right, well, let's see. What do we know about 81? Well, we know it's the same thing as 9 squared. And we also know it's the same thing as 3 to the 4th power. Okay, but that's not quite what we need, because we need the base to be 1/3, not 3. So 1/3 is the reciprocal of 3. So what can we do with exponents to get the reciprocal? Well, we can make the exponent negative. So 3 to the 4th is the same thing as 1/3 raised to the negative 4. All right, and then we can just cancel out log base 1/3 and that 1/3, and then our final answer is equal to negative 4. All right, number 11, we have log base 64 of 4. Okay, so we have to figure out how we can replace 4 with 64 to a power. So what do we know about a relationship between 4 and 64? Well, I know that 4 times 4 is 16 times another 4 equals 64. So that means that 64 is the same thing as 4 to the 3rd power, which also means that 4 is the same thing as the cubed root of 64, because 4 times 4 times 4 equals 64. So then we can write that. So remember, our goal is to write it as 64 to a power. So the cubed root is the same thing as the 1/3 power. So it turns out that 4 is the same thing as 64 to the power of 1/3. So then we can cancel this and this, and our final answer is 1/3. Okay. So number 12, log of square root of 10. So since it's not showing the base, we know the base is understood to be 10. Okay. All right. And then we want to rewrite the square root of 10 as 10 to a power. So we know the square root is the same thing as the 1/2 power. So then we can cancel those, and then our final answer is 1/2. All right, so that base of 10 is like invisible. It's kind of like having, same kind of concept as having like an invisible exponent of 1 or an invisible coefficient of 1. So if you're writing the final answer, you just write it as log. But when you're trying to simplify things, you can fill that 10 in there just to show it, just so it makes more sense when you're working out a problem. All right, but if it was the final answer, you wouldn't write the base 10. All right, so number 13 says log base e of 1 over e to the 5th. So there's our friend e again. Okay, so we just need to replace this with e to a power. So 1 over e to the 5th is the same thing as e to the power of -5. And then we can just cancel. And then our final answer is just -5. Alrighty. Okay. All right. So sometimes we might want to change an equation between exponential and logarithmic form. So this could be useful when you're solving an equation. All right. So if you have, for example, b to the p equals a, that is the same thing as log base b of a equals p. So you can switch between these two forms, okay? So it's kind of like if I said that I had, 2 plus 3 equals 5, and then I said, well, that's the same thing as saying 2 equals 5 minus 3. Okay, so it's kind of like that sort of a concept. It's just another way of writing the same equation. All right, so if you have log base square root of 3 of 9 equals x, so let's switch that over into exponential form. So the base there is the square root of 3. And then the p is x. And then the a is 9. So square root of 3 raised to the power of x equals 9. Is that basically the exponential form of that same equation? So number 15 says 3 to the power of 4 equals 81. All right, so we want to write that in log form. So the base is 3, so it's going to be log base 3 of, so the a is 81 equals p, so that's the power is 4. So log base 3 of 81 equals 4. So that's the logarithm form of that equation. Okay. All right. Yeah. Okay. So that's probably a good, we still have more 4.3, but I'm going to go ahead and cut this. So this is part B. So there's going to be a part C for 4.3. All right, so part C will begin with the properties of logs. All right.